Hello and welcome to the fourth of 5 short videos to help you to prepare for the start of A-level chemistry. And this video is about bonding and structure. Now a lot of students find this quite tricky, but there are only 3 bonds. Yeah, bonds are what hold the particles together. And it's important to remember that all the bonds are strong, all 3 bonds are strong. So a lot of energy therefore will be needed to break those bonds, and they will have a high melting point and boiling point. So let's go through each bond. Let's start with an ionic bond. An ionic bond is between a metal like magnesium and a non-metal like oxygen, so magnesium oxide. That is not the definition. That's just how you recognize an ionic bond. Yeah. So if you have magnesium, magnesium's in group 2, so has 2 outer electrons. Oxygen is in group 6, so has 6 outer electrons. So in order to have a full shell, the magnesium will give its 2 outer electrons to the oxygen. So we're drawing a dot and cross diagram here. And the magnesium doesn't have any electrons now in the outer shell, and it will be an ion with a 2+ charge, and oxygen has got the 6 dots, its own electrons, and the 2 crosses from magnesium, and has a 2- charge. I do have other videos on this going into a bit more detail. And the definition is a strong electrostatic attraction between oppositely charged ions. That's one of the 3 bonds. The second bond is metallic bond, and a metallic bond is within a metal, not between metals. So for example, magnesium. Yeah, you've got magnesium atoms, and what happens, the magnesium atoms, the outer electrons are lost, and they become magnesium ions, 2+ ions. And the outer electrons are delocalized, which means that they are free to move through the structure. Yeah, and that's a metallic bond within a metal. And the definition is a strong electrostatic attraction between positive metal ions and delocalized electrons. Can you see that that first part is exactly the same as an ionic bond? Okay, the last bond is a covalent bond. And a covalent bond is between non-metal atoms. And that is not the definition. Okay, that's just how you recognize it. So for example, carbon dioxide. Carbon is a non-metal, and oxygen is a non-metal as well. So there's the actual the structure, formula of carbon dioxide. There is a covalent bond, a double covalent bond. So when we're drawing the dot and cross diagrams, it's a shared pair of electrons. So you've got a dot and a cross, and a dot and a cross, a double covalent bond. And the same on the other side with the other oxygen atom. And then oxygen has got 6 electrons in total, 6 dots. So you need to put in total another 4 dots and another 4 dots. Again, I've got another video showing how to do this if you'd like to practice. And the definition has the same start, strong electrostatic attraction between a shared pair of electrons and the nuclei of the bonded atoms. Okay, so all of those 3 bonds, ionic, metallic and covalent, are strong bonds. But why is carbon dioxide a gas? Carbon dioxide has covalent bonds, but why is it a gas with a low melting point and boiling point? And that's because of the structure. So the structure is how the particles pack together. The bond is what's holding the atoms together, and the structure is how those particles, they all pack together. So let's go through the structures. If the bond is ionic, then the structure is always giant ionic. Yeah, the structure is giant ionic. Giant means many. And the word lattice, you can include the word lattice. Lattice just means a regular pattern. So if you take magnesium oxide, for example, that shows a ratio, that formula, which we call an empirical formula, shows the ratio of magnesium to oxygen. So the magnesium ions to oxide ions is a 1-to-1 ratio. But actually there are many a giant ionic structure. There are many magnesium ions and oxide ions, actually in a cubic structure with the opposite charges next to each other. And it's got a high melting point because in order to break this up, you have to break the strong bonds, and a lot of energy is needed. So if the bond is ionic, then the only possible structure is giant ionic. If the bond is metallic, then the only possible structure is giant metallic. We've shown that example already with the positive metal ions and the delocalized electrons. And again, it's a high melting point because you're breaking those strong bonds. Now for covalent, if the bond between the particles is covalent, between the atoms, then there are two possible structures. You can have giant covalent, so for example diamond, which has carbon in a tetrahedral, 4 bonds in a tetrahedral structure. I'm not very good at drawing that, but each carbon atom has 4 covalent bonds, strong covalent bonds. So when you want to melt a diamond, you have to break those strong covalent bonds between the carbon atoms, therefore it has a high melting point. But you have another structure, so you could have giant covalent or you could have simple molecular, simple molecules. So if you take carbon dioxide, for example, yes, there are covalent bonds inside the molecule, a shared pair of electrons, but between the molecules you have intermolecular forces, forces that are between the molecules, and these are weak, and that's what you're breaking when you are melting and boiling. You are breaking the weak intermolecular forces, and that's why molecules like carbon dioxide have got a low melting point. Now that was a very quick run through just to help you get started for A-level chemistry on bonding and structure. When you study it at A-level, there is a lot more to this as well, but this was just an introduction, so I hope you found it helpful. I will make a worksheet to go with it as well, and my last video is going to be on acids, alkalis, bases and salts. Thank you very much for listening.